Hi, everybody. Today in class we worked on dividing a fraction by another fractional part, and it was similar to what we did yesterday when we looked at dividing fractions by another fractional part. With yesterday, they had the same parts. So, for example, Molly had 1 3/8 cups of strawberries, and she needs 3/8 cups of strawberries. We knew that 1 3/8 is the same as 11/8, and we could easily divide that by 3/8. When we have common parts, it really ends up being 11 divided by 3, or 11 thirds, because 8 divided by 8 is just 1. And 11 thirds gives us 3 sets of 3 in that 11 with 2 thirds left over. So she could make 3 2/3 batches. So there's just a quick review on the shortcut way we learned when we had common denominators, or the common parts there. So if I take a look at what we did today, today we had a similar problem. Molly's friend Xavier also has 11/8 cups of strawberries, and he needs 3/4 cups to make a batch of tarts. How many batches can he make? Draw a model to support your solution. Well, what we talked about in class is that right now, this is really going to be difficult to draw a model because we have 11/8, but then we're trying to find 3/4 or 3/4 of 11/8, and they're different size pieces. So a lot of the students said, hey, well, I can rename 3/4. 3/4 is equivalent to 6/8. If we just call 3/4 cup 6/8 cup by relabeling it, we can go ahead and we can easily solve that problem, because now we have 11/8 that we're equally going to divide up into groups of 6/8. So just as a quick review, it'd be the same as saying 11 divided by 6 and 8 divided by 8. So I know 11 divided by 6 is 1 full set with 5/6 left over. 8 divided by 8 is 1. Well, any number divided by 1 is that number that we started with. So our answer is 1 5/6 batches. Some students liked that method, and other students liked to rewrite the division statement as multiplying by the opposite. So instead of keeping it division, they said, I will do the opposite of the opposite. So the opposite of 6/8 would be 8/6. And they chose to do it this way by realizing that they can cancel out the 8's, divide both parts of the numerator and denominator by 8, leaving 1's. And then we have 11 times 1 is 11. 1 times 6 is 6. And 11/6 is an improper fraction, which can read 11 divided by 6. Well, I can get 1 full set of 6 out of 11 with 5/6 left over. So again, I still get the same answer. To show again what that would look like in a model, I can see that I can set up a model to draw out 11/8, which is right there in blue. So out of 11/8, when we're trying to pull out 3/4, and we know that we've already named 3/4, renamed it 6/8, it's equivalent. When I go through, I can find right here is 1 set of 6/8. And when I go to pull out another set of 6/8, it's right here, but it's not complete. Out of that set, I have 5 out of the 6 pieces. So our answer ends up being 1 5/6, either 11/6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 1 5/6 batches. So that's what we worked on in class. Either way to solve that problem works. The visual just helps make sense of it, of why 3/4 is the same as 6/8. We used equivalent fractions. So I hope this helps make a difference.